Look at creating quadratic equations from data. They've given us some information, okay? We simplified what they gave us, but a 0 or a root or an x-intercept, this is one of the coordinates. The other x-intercept, this is the coordinate. And they've given us a point, which happens to be a y-intercept, but any point would suffice for what we're doing here. Okay, so we have 3 pieces of information. They want us to build an equation from this, and they've told us that it's a quadratic equation. So there's essentially 3 equations we can kind of pull from. You have your standard form, which is your ax squared plus bx plus c. Okay, so we have your standard. You have the function could be vertex form, which is a times x minus h squared plus k. Vertex. I suppose I should have wrote these before. And we have our factored form, which is a x minus r, x minus s. Are the letters they usually use, but they could essentially be any letters. Those 2 just represent the roots. So this is your factored form. Okay, so the first thing we want to do is choose which one is going to work best. A, B, and C are kind of arbitrary. Actually, I shouldn't say that. C is the y-intercept of a quadratic, and we actually have the y-intercept. So we know C in this case would be the number 6, but A and B are a lot harder to work with. You can kind of derive them if you have like a point and a vertex, but we don't quite have this information, so this is probably not the best version to use. Okay, the vertex form, you essentially want the vertex, which we can almost find. We have 2 zeros, but that's all the information we have. We know the x value of the vertex would be between them, but the y value will be hard to calculate because we don't have an equation, so we can't really use the vertex form. Okay, so really we're looking at the factored form. And the factored form, we need an r and an s, which is both of the zeros. We both have those. And then we need another value so that we can isolate for a, so any point along it, which we have. So we're going to use factored form to do that. So kind of choosing the equation to use is the first step about this. Okay. Now they've told us that the first intercept was -3. So we're looking at x minus -3, okay? And the other one is x minus 1/2. So this -3 is going to become a positive. So we have a x plus 3, x minus 1/2. That's great information. We have a coordinate. Our coordinate at 0 and 6 is essentially an x and a y coordinate. We don't use y, we have f at x, but essentially f at x is replacing the y. So what we're going to do now is we're going to replace both of the x's in the equation with that 0, and we're going to replace the y in the equation, or the f at x, with 6. And that will leave us just one variable, which is the a, so we can then isolate for a. Okay, so we replace y with 6 is equal to, a is still unknown. The x is 0, so 0 plus 3, 0 minus 1/2. So now this is just like a practice in isolating a variable. So 6 is equal to a, this becomes 3 times -1/2. -1/2 is -3 over 2, -1.5. I'm going to leave it as a fraction though. So 6 is equal to -3 over 2a. Okay, these all just kind of multiplied together. And then I need to isolate for a. So I have a fraction here. And you could do this one step at a time. You could bring the 2 up and then divide by 3. Or when I bring it over, I can just multiply by the inverse of this fraction. So -2 over 3 instead. And that's the exact same process. That's a quick way of moving fractions if you need to divide by that value. Okay, so when we do that, that gives us.
Oh, okay, yeah. Or I could.
You could just do it 2.
Can I just do it on a calculator?
Yeah,
like
of course you can.
6 -3 over 2.
Yeah.
Okay.
And that will give you 1.5, and you can use decimals. But this is a quick way to do it kind of without having to work with any decimals. When I multiply fractions, I do -2, so top by top, bottom by the bottom. So -2 times 6, that gives me -12. Okay, over 3 is equal to a. And -12 over 3 is -4. So my a value is -4, which means I now take this equation here. Remember we said this was all good except that we're missing an a value. So our equation is now, I should have pointed down here, f at x is equal to our a value is -4. Put an equal sign there. And the rest of the factored form is x plus 3, x minus 1/2, and that's it. And then if they ask you to put it into another form, you now have enough information where you can kind of find the vertex, and you can put it in the vertex form, or you can expand into and simplify, and you can put it in the standard form. But we used what was easiest for us to start with,
Yeah.
and then we can kind of move between those if we need to.